Hello, my dear students. Hope you're all doing good. Good morning. Right. So, how many of you are there? We have 11, 10 of you, I guess. Yeah, I think 10 of you are there. Right. So, I think we have planned for a quiz today. Right. So, we'll go on to the quiz today. Right. As planned. Is everyone ready? I asked you to prepare group 15, right?
Yes.
Is everyone ready?
Yes,
right. Good. Maybe before we move on, I think I have to, like, did you come up with the conversion that I asked you to do? Like last class, maybe I'll show you that. Last class we stopped with the conversion, isn't it? Where was it? Is it here? Is it this or this? Yeah, this one. Right, this is where we stopped, right? So I wanted you to convert this particular compound into this compound. Did you come up with an idea for this, guys? Anybody got an idea? Okay, fine. So maybe let me, yeah, tell me.
Not getting.
They're not getting? Okay, good, fine, no problem. At least you tried. That's the point. Right, okay, let me do it then for you. So let me take this compound. Okay, now I can go for Wood's reaction, right? Sodium in the presence of, I think it's acetone. Right? You have to use 2 molecules of this, 2 moles of this. So what will happen now? This will become doubled, correct? This molecule will become doubled. Say, for example, if you start with CH3Cl, you go for sodium in the presence of acetone, right? You are going to get what? CH3CH3. Now see where you are forming the bond. Basically, if I take 2 moles of this, CH3Cl, ClCH3, you remove this and you form a bond here. That's exactly what you're doing here, isn't it? Now see where is the bond here? The bond is here. Now you are going to make sure that the bond again forms in this case only. So can I write the compound like this? CH3, CH, CH3. Now wherever I had the chlorine, now you have to add it here. So that's going to be CH, CH3, CH3. No issues. Now this compound is a little complicated looking. So now if I write it properly, how will I write? Say now I can take this as the main chain or say this as the main chain. How will I write it now? CH3, CH, CH3, CH, CH3, CH3. Yes, this is the whatever the compound is, the same compound is here. Right? Now, what I have to do, I have to make a double bond somehow, right? So now I have to go for bromination, Br2 in the presence of light, H nu. Now what will happen? Obviously, the this is tertiary carbon. This is also tertiary carbon, or this is secondary carbon. So this is secondary carbon. Secondary carbon. These are primary carbons. Obviously, secondary is more favorable for a free radical substitution. So now, if you do that, right? If you do that now, you are going to get CH3 C Br CH3 CH CH3 CH3. You can put in this carbon also, not a big deal. It is going to be same. Either you put the bromine here or here, doesn't matter. Now, can you answer this question? Why am I not going for chlorine, Cl2 in the presence of H nu? Anybody knows? Why am I not going for Cl2 bar H nu? Why I am going for Br2 bar H nu? Why? Anybody? Any guesses? Okay, so you don't know. It's because Cl2 is more reactive and less selective. In the sense that, see, you have how many possibilities? You have 1, 1, 1, 1. All these are same carbon atoms. All have equal probabilities. And the second possibility is this, either of these 2 carbon atoms. Okay, now chlorine is so highly reactive that it will not have the time to see where to attack. Wherever it gets, it will attack, right? But bromine, in the sense, is little less reactive, but more selective. Okay, so obviously it is going to go for most stable product. The most stable product is where I found the BR here. That means the product is shown here, right? That is the reason why we go for BR2 and not Cl2, right? Don't confuse. This is not a double bond, people. So, okay, right? Now this is what we have in hand. Obviously now I have to make a double bond between these two. What I have to go for? Alcoholic KOH, elimination reaction. Now if we do the elimination reaction, you are going to get CH3, C, CH3, double bond, C, CH3, CH3. That's it. See where you started with. Again, second, little make it smaller and show you. Right? So you started from here, this compound, right? You went for Woods reaction, you doubled it, then you went for bromination, make a bromine here, then you went for elimination. This is where you end up with, and that is what is asked for. You can see this product, this compound, this compound. Okay, everybody got it? Any questions in this?
Sir, what if it is aqueous KOH, sir? Can you, the last step?
The last step.
Instead of alcoholic KOH, what if it is aqueous KOH?
Oh, good question. Now, if I put aqueous KOH, what is going to happen is OH minus is going to act as a nucleophile. Okay, here what is happening is this KOH acts as a base. Okay, alcoholic KOH acts as a base. Aqueous KOH is also a base, but it can produce OH minus ion. If I dissolve KOH in alcohol, the OH minus ion is not produced. Okay, but if I dissolve KOH in water, right, OH minus ions are produced, and I'm going to have nucleophilic substitution. So the product will be formed is this C, OH, CH3, C, CH3, CH3. This is what you will get if I put aqueous KOH. Okay, aqueous KOH will undergo nucleophilic substitution. Alcoholic KOH is going to act as a base, so I have elimination reaction. Okay.
Okay.
Right. Good. That's a good question. Right. Any other questions anybody has from this?
Okay, I have a doubt, but not from this.
Sure, tell me.
So in the P block element, is it necessary to remember the names of all the elements in the group?
Yes,
group 13 all
in every group, you have to at least, like, it's better to remember all the elements. Okay, nitrogen, phosphorus, arsenic, bismuth. What is the last one?
Antimony.
Antimony and bismuth. Right. So now you have to remember all the elements, and not only in that group, in all the group, you have to remember the elements. Okay. Right? If not, it will become a little difficult. It's not that easy. So many times you don't have to mug it up also, because you will be using it so many times. Eventually, it will stay in your mind. You don't have to take efforts for that. It's very easy.
Yes.
Okay. Any other questions anybody has? Can we start with the quiz? Are you ready?
Yes, sir.
Okay, good. Like, I have to look into the groups again. Once again.
Sir,
yeah,
before I have a question, sir. Can I answer that one, sir?
Yeah, sure. Tell me.
Sir, why is inductive effect more stronger than resonance when it is coming from for electrophilic substitution, sir?
Okay.
Actually, there's a question in the textbook also, sir.
Okay, why inductive effect? Like, for example, see, space, right? See, understand that inductive effect not only for the electrophilic substitution, for anything for that matter, inductive effect is not that powerful, right? But see, why am I telling you is because, say, I know CH3, for example, if I take CH3, CH2 plus, or I'll take the question that you asked itself, right? The perfect example I can take is Cl, chlorobenzene. Okay, now chlorobenzene, if I look at into the inductive effect of chlorine is an electron withdrawing group because it is highly electronegative, right? Now it is going to have electrons getting pulled from there. That's what we expect. Okay, that is one effect. Obviously, by inductive effect, this is electron withdrawing. Okay, but for electrophilic substitution to happen, right? For electrophilic substitution to happen, you should have some negative charges in the ring somewhere. Okay, you should have some negative charges in the ring somewhere. Only if I have negative charge, that can be attacked by the positive charge. Is it not? right? Now, by inductive effect, if I'm telling that the electron is getting pulled by the chlorine, obviously what I expect is positive charge on the ring, is it not? Because electron is getting away from the ring, right? But that is one of the way of looking at it. But if you see, chlorine has lone pairs on them, right? Now, if you look at, then it can, now if it has lone pair on them, it is going to have resonance effect. Now, what kind of resonance effect? It is going to show me plus R effect, in the sense that plus R means electron donating group effect. Okay, now if this comes, this bond breaks, now you see that there'll be a negative charge here. And what will be the next step? This will come, this will break, you'll find a negative charge here. So the most important thing for an electrophilic substitution is that in the benzene ring, I should have some negative charges. Okay,
Sir,
now, yeah.
sir, what about the carbocation, sir?
Yeah, we'll come to that. Wait, I'll come to that point. Now we'll finish this. So since I need to have negative charges, obviously the resonance only will make a very good explanation. But if I go for inductive effect, that doesn't explain how is it that the electrophile is able to attack this. Right. Now, when you go for this one, let me take this example. Right. Say I have CH3O CH2 plus. Okay. Now, what you understand here? What you understand here is that I expect this molecule to be unstable. Okay. Now, why is it unstable? Because I know oxygen is there, highly electronegative element. It is going to pull the electron towards itself. Electron withdrawing group, EWG is this, right? So I expect that the charge will increase and it is going to destabilize this carbocation. Okay. But what I see in reality is that this actually is stabilized. Right now, how is it stabilized? Is very simple. I have a lone pair on oxygen that will get donated here. So I'll be able to write resonance structure like this. I'll be able to write this as CO double bond CH2, and oxygen is going to have a positive charge. Okay. Now, like this is just a theoretical concept. Remember that all these inductive effect, resonance effect, all these are theoretical concepts. But whether that particular molecule is stabilized or not, that I will be able to do it experimentally. I'll be able to have proof that this molecule is stable. Right now, how do I explain this? If I take inductive effect into the picture, obviously I see that it is becoming unstable because of electron withdrawing nature of oxygen. But in reality, I see them that is stable. How will I explain it? Obviously, only with the help of resonance. This happens, and that is why it is getting stabilized. So you get the point. It is about the end result. In the end result, which is dominating 99.999% of times, if you have both inductive effect and resonance will be dominating for sure. Yes, did I answer your question?
Yes, sir. Okay, sir. Understood, sir. But in the NCRT, it is given inductive effect is stronger than resonance, sir. I had a question.
Impossible.
That topic,
Impossible. Like, send me that particular wherever you
Sir,
read that.
it
Send
is
me
in
in
page
WhatsApp.
number 315. I'll send you in the WhatsApp now, sir.
Yeah. You send me in WhatsApp. We'll discuss there.
Okay, sir.
Okay.
Okay.
Impossible that they will tell that inductive effect is more stronger than resonance. Impossible. Let me look into it if they said that. Why they said that. Okay, you send me in WhatsApp. We'll discuss there. Any other questions? Anybody has? Yeah, good then. So fine. We spend 15 minutes, good quality time on organic. As I told, organic is my favorite, right? Anyways, but you can always ask me questions like organic. I'll always love to answer your questions in organic. Not today, any day for that matter. Right. So today is the quiz day. Right. But I have to, before that, I have to look into the groups, what and all I have. Did I write it here in P block?
Sir, I just sent a message, sir.
In the this thing.
Yes,
WhatsApp. 1 second. Okay. Though resonance halogen tends to stabilize the carbocation, and the effect is pronounced also in parapressure. The effect is strong. Impossible.
There it is given inductive effect is stronger than resonance and
No, no,
causes.
in this particular, why they are telling, that's what we didn't understand. Okay, okay, okay. Okay, what they are trying to say here is that, right, say when I compare this chlorine with, say, for example, OH, for example, right? Now, obviously, this is both of them in resonance, in both of them resonance is happening, right? In both of them resonance is happening, and obviously in both of them, they are similar kind of groups because this is also an electron withdrawing group, this is also an electron withdrawing group. Okay, but in this case, resonance will be more than in this case. Why am I telling it like this? Is because for resonance to happen, right? For resonance to happen, the orbitals involved should be of same energy. Now you understand here, this electron is coming from 2p orbital of oxygen, and it goes into 2p orbital of carbon, right? But here, if you check, the lone pair is coming from 3p orbital of chlorine, and here it is going into 2p orbital of chlorine. So 2p, 3p, there is always an energy difference. Okay, 2p, 3p, there is always an energy difference. So here, that is why they say that, say, in this particular case, right, in this particular case, resonance is not that dominating because it is between 2p and 3p. But here, it is perfectly okay because it is between 2p and 2p. Perfectly all right. I think this is what they're trying to say. Now, what you do is send me the entire picture, like send me the entire pages picture. I'll look into it. Why exactly are they telling this? I don't know where the carbocation comes into this picture here, because in case of electrophilic substitution, what I have is only negative charges. Okay, you send me the entire picture. I will look into this.
I sent, sir.
You send the entire picture?
Yes, sir. Entire example I sent, sir. Understood now, sir.
You understood?
Yes,
okay.
sir.
Although chlorine is an electron withdrawing group, yet it is orthopara directing. Exactly, that's the reason. Even though chlorine is an electron withdrawing group, it is orthopara directing because of resonance. As simple as that. Okay. Chlorine withdraws electrons, resonance effect releases electron to resonance. Through inductive effect, chlorine destabilizes the carbocation, obviously, but obviously through resonance it stabilizes. Yes, that's exactly what they're trying to tell here. That is just the point which they're trying to, you send me, is just not the simple point. It just continues after that. Read about it. Now you'll understand.
Okay, sir. Thank you, sir.
Okay, right. Any other question anybody has? Right now I have to look into the groups which where is the thing which I converted into groups? Where is it? Where is it? Okay, it's here. Right. So group 1, are you ready? Ananditha, Mithun, Ashik, and Satyapriya. All four of you are there.
Yes, sir.
Mithun present, yes, sir.
Mithun present, Ashik is present, Satyapriya is present.
Yes, sir.
Okay, good. Right. Group 2, Akshaya, Nikhilesh, Venisha, Suryamuthu, all four of you are there.
Yes, sir.
Okay, all four of you are there. Okay, group 3, Harini, Nantakeshwar, Ananya, and Monisha, all four of you are there.
Yes, sir.
Okay, all four of you are there, I guess. Okay, group 4, Rohan, Sashank, Harshita, and Rohan, I asked you to find who is this another people. Did you find?
No, sir, we couldn't find.
You couldn't find?
So I think it's Susindran, sir.
It's the same?
Susindran.
Susindran. Okay, is he present today? Can you check and tell me? Look into the group members who are all on there. Is he present, Susindran?
He isn't here today, sir.
He isn't here. Till then,
I don't think he was
Rohan,
at last class also, so I'm not sure if he's still in the chemistry.
okay, not a big deal. Then in group 4 only you have only in group 4 alone we have 3 people. Then it's fixed. Okay, all the other groups you have 4, and group 4 alone you have 3 people. Right. Okay, and these are the rules, people. Right. I will ask the question first. Like obviously the first question goes to group 1. Okay. Now if group 1 is not okay, for every correct question you will be getting +2, and there's no negative marking here. Okay, no negative mark for wrong answers. If you don't answer, you get 0 mark. Right. And if you don't answer, it will pass on to group 2. Right. And if group 2 answers the past question, they will get +1. Right. And if they don't answer, nothing. And it does not, if they don't answer, it does not pass to group 2. No, I mean group 3. Only the next group can get the chance to answer if the previous group is not able to answer. Okay, it is not like if group 1 doesn't answer to group 2, group 2 to group 3. No. If group 1 doesn't answer, the only chance will go to group 2. If no, that is also not, if group 2 is also not able to answer, then I will give the answer to the question. Okay, I hope that everything is very clear. For every correct answer, if it's your question, if you answer it correct, +2. If it's a past question, you will get +1. If you don't answer, you will get 0. Okay, very simple rules, right? Okay, so then we'll start. Let me bring my book. 1 second, just give me a minute. And regarding this quiz, I'm just doing a quiz because just to make it interesting. Because see, do not worry about winning or losing. Every group, like whether it's a question for group 1 or 2 or 3 or 4, irrespective of that, each and every one of you will write down the question. When I dictate the question, everyone will write the question, and when you get the answer, you will note down the answer. Okay, this is not for some activity stuff. This is for your learning. This is how we are going to learn the chapter. Remember that. Okay, right? So every question, everybody has to write. Everybody has to write the answer also. Be very careful, right? If not, the loser is you, right? The group only, if you're gonna take down questions, only come for you. You will get only very less number of questions. Okay. Okay, so today is group 15, right? Okay, your group 1's first question. The question is for group 1. Okay, let me make a table actually. So, group 1, group 2, group 3, group 4. Okay, this will continue till this chapter ends. Okay, right. Now your question, group 1. Everybody has to write the question. pH3 has lesser boiling point than NH3. Why? And you will have maximum 1 minute to discuss among yourself. You cannot discuss in the meeting, you can discuss in WhatsApp. Okay, or you can discuss here also. Actually, like not a big deal. Not a big deal. You can unmute yourself. You can talk to your group mates here itself. Let us hear the discussion. Not a big deal. But anyone has to give me an answer. So pH3 is having lesser boiling point than NH3. What is the reason? You have 1 minute to answer. Guys, do you mind like opening your videos? Is everyone in the correct situation to open your videos? Because I don't want any cheating here. Okay, can you all open your videos? I want everyone to open the videos. Go for it. Yeah, you can discuss here. Don't worry. Like nobody's gonna what to say. this thing. 1 second. I'm just going to how to go into the meeting. Okay, I hope every meeting all of you have. Is everybody gallery view? Yeah, I see only Nandakishore and Sashank has opened the videos. Come on, everybody open the videos, please. I mean, if you're not in a perfect situation, it's fine. Yes, can everybody open the videos? Sir, my laptop has a camera problem in Zoom, so I rectified next class. Please explain me today. Sure, sure. Right. So just like this is just for just for the thing that nobody is cheating us as such. Nothing else. Okay, or else you can close your videos, but make sure that you don't cheat. Like this is not some big competition that you have to cheat and win. There is nothing like that. Okay, so make sure nobody cheats your answer. If you don't know what's your question, answer. If you don't know the question, discuss. And if you're not still able to get the answer, it's completely all right. Okay, you can close your videos, not a big deal. Okay, right. Fine. Okay, so I think the 1 minute got over. You want to answer group 1?
Yes, sir. Actually, the boiling point increases from top to bottom, and NH3 has high intermolecular force of attraction between the constant molecules, that is the hydrogen molecules, whereas pH3 is somewhat electronegative, so there is no hydrogen bonding between them. So NH3 has
yes,
more boiling point because, yes, sir. Thank you, sir.
Okay, I understood. So the answer is hydrogen. That's it. Right? Now NH3 can form hydrogen bond, TH3 cannot form hydrogen bonds. Okay, but what we expect in general is that when I go down the group, the boiling point has to increase. Remember, for boiling point is directly proportional to the molar mass. Right? More and more is the molecular mass of the compound. More and more will be the boiling point or melting point for that matter. So we expect NH3 to have a lesser boiling point than pH3. But here what is happening is hydrogen bonding is dominating. Whenever hydrogen bonding is there, that will always give up, that will always get more boiling, more stronger interaction between the NH3 molecules. Right? Absolutely correct. So group 1 gets plus.
So I have a doubt, sir.
Yeah, tell me.
Textbook given after arsenic, the boiling point decreases to antimony and bismuth. Sir, is there any reason why?
After arsenic, the boiling point decreases.
Yes, a melting point decreases.
Melting point decreases. Okay. Now maybe it is. Sir? Yeah, maybe it is because say now for melting point and boiling point, generally the van der Waals force is what is we have to look at, right? So what happens is since the atom is becoming so big, right? After the atom is becoming so big after a certain point, the electron cloud will be very, very far away from each other. So this one and the next one will not be able to have proper van der Waals interaction.
You can say the reason is size of gas.
Size of gas.
Yes, sir, size of.
Exactly, that's the reason. Because when size increases, now remember, whenever the size is so big, right? Remember, area of contact is also very, very important for your van der Waals force. Okay. Now, if the size is too big, that area of contact will be there, but the thing is, it will not be an efficient area of contact. That's the reason why we say that the melting point generally decreases from from arsenic after antimony and bismuth.
Okay, sir.
Right. Okay. So group 1 gets +2. Now the question goes to group 2. Right. Now the question is why NO2 dimerizes. right? Why does NO2 undergo dimerization? You have 1 minute to answer the question. Group 2. Do not type it in Google, people, please. If you know the answer, it's okay. If you don't know the answer, also it's okay. Anyways, you're not going to know the answer now. Getting the 2 points for your team is not a big deal. Because for all these questions, if you Google, obviously you'll get the answer, but that really kills the spirit of having a quiz. Do not do that, please. Yes, I think the 1 minute got over. You want to answer group 2? Group 2, are you there? Group 2, I have Akshaya, Nikhilesh, Vanisha, and Suryamuthu. Yes, any answers?
Sir, is it
Yeah.
due to the presence of unpaired electron on nitrogen?
Unpaired electron in nitrogen. You're partially correct. I want the exact answer. What is the unpaired electron? If I have any unpaired electron, what is the species called as? What is the species called as? If you don't answer this, you'll get only 1 point, +1, because that's only partially correct. Yes, any answers? What is that? If I have one single unpaired electron, those kind of species are what are called as? Okay, so if there are no answers, I'm just giving you +1. Right. So the reason here is that if you look at the structure, like this is how you must write in the exams, people. You must write the structure of NO2 first. This is the structure of NO2. Right. So nitrogen has 5 valence electrons. Now you will see that there are 2 electrons here, 2 electrons here, gone. So there is 1 electron left out. Right. Now this single electron will be there, and these kind of species are what are called as radicals. Isn't it? These are nothing but free radicals. Right. So you have to tell that because of the presence of this unpaired electron, NO2 will be acting as a radical, and radicals are unstable. Okay, because of this single unpaired electron, NO2 is unstable, so that it get dimerized. How it will dimerize now? This is how it will dimerize. Right, now you have this electron, right? Now this electron and another nitrogen will have another unpaired electron. They will make a bond, so they will exist as N2O4. Correct, right? This is how you must answer the question. You must tell that there is an unpaired electron, it is going to act as a radical, that is unstable, that is why it undergoes dimerization. Okay, fair enough, right? That I gave you +1, group 2, right? Because
Yes,
this is a
sir.
very, right? Okay, good sport. Okay, next question for group 3. Okay, group 3. What happens when PCl5 is heated? You have 1 minute to answer the question. I don't see any discussion. If you're okay, you can discuss here or you can discuss on WhatsApp. Okay, but discussing and chatting will be a little difficult. You can talk to your group mates here itself. That will save a lot of time. Okay, is the answer ready? What happens when PCl5 is heated? Group 3. Group 3 is Aruni, Nandakishore, Ananya, and Manisha.
Sir, does it decompose to PCl3
And
Cl2?
yes, that's the answer. Right? You should tell that it will decompose to form PCl3 and Cl2, and you must write the reaction. PCl5 on heating will give PCl3 and Cl2. Okay. Yes, correct. Group 3 gets +2. Okay, next question to group 4. Right. The question is BiH3 is the strongest reducing agent among group 15 hydrides. Why? Group 4, this is a question. BiH3. Yeah, right. So what I was telling is, yeah, why BiH3 is the strongest reducing agent among group 15 hydrides. So basically, you are talking about NH3, BH3, SBH3, BiH3. So obviously, the next one you leave, right? Arsenic is there, ASH3. All there among that, yeah.
Sir, I think it's BiH3 is least reducing agent because of its least stability, and
Stability, okay.
there is increase in the size of central atom.
Increase in the size of central atom. Okay, so if there is increase in the size of central atom, what happens?
Sir?
If there is increase in the size of central atom, you're telling that unstable is not a correct word, but still I will take it. Right. If the central atom is...
No, sir, I said least stable.
Yeah, that's what you're telling, that it is least stable, but again, that is not the correct way of putting it, but still I will take it. But if I have the central atom size to be increasing in this particular case, why is that this becoming less stable?
Doesn't hold the electrons it has properly.
Doesn't hold the electron.
So it's not as stable.
Actually, talking in terms of stability itself is not a correct way of doing it, right?
Maybe the enthalpy decreases.
What enthalpy?
Ionization enthalpy, sir.
What enthalpy?
Ionization enthalpy.
No.
Bond enthalpy.
Exactly. Yeah, correct. Bond enthalpy of what? Bond. We are talking about certain bond, right? Which bond are we talking about? Bond enthalpy of which bond you're talking about?
Pi bond, sir. Pi bond.
In the sense that there are two atoms, right? Which two elements is bond are we talking about? You are telling that the bond enthalpy is less.
Sir, it's
okay.
between,
bond enthalpy of which bond?
It's between the group 15 element and the hydrogen.
Exactly. We are talking about the BiH bond. Okay, so the BiH bond, it's very easy to break the bond. The bond enthalpy is very less. So obviously hydrogen can come out very easily. And this hydrogen can go attack something else and reducing that particular compound. Are you able to understand now? Right? The BiH bond is very weak. Right? That means that less amount of energy. What do you mean by bond enthalpy? Bond enthalpy is the energy required to break the bond. Okay, so very less amount of energy is required to break the bond. So hydrogen can easily come out and attack the next substance, thereby reducing it. Now the question is, why the bond enthalpy is less? For that, the answer which you said, there is the central atom is very big. Now always remember, people, when I have a big cation and a small anion, right? Remember the size difference between the bonding atom is inversely related to the bond strength. In the sense that if I have a smaller species and smaller species, stronger bond. If I have a big species and a big species, again a stronger bond. But if I have a big one and a small one, there the bond strength is very small. Right? Bismuth is very big. Hydrogen is so small. That's why there is very less bond energy. It's very easy for us to break the bond. Okay, right? So all these should be in the picture. The easiest way to tell it is BiH3 is the strongest reducing agent because the BiH bond is the weakest, or say the bond enthalpy of BH very bond is very less. Hydrogen can come out. And the next reason why the bond enthalpy is less, because there is huge size difference between bismuth and hydrogen. This is how you must answer the question. Okay, right. I will give you +2. Because you even though I little helped you, not helped you in the sense, but I have to ask you the question so that you'll be able to get it right.
I think that +2 should be in group 4.
Group 4. Sorry, I'm sorry. Absolutely. Sorry. Right. So fine. That's about the first round. Right. Next question for group 1. Okay, group 1. Your question is why PCl3 fumes in moisture. Okay. Why PCl3 fumes in moisture? You know what is fuming, right? A lot of fumes coming out. When there is moisture present, PCl3 will give fumes. Why? You have 1 minute to answer the question.
Sir,
Yes.
does it react with water and oxygen is produced out?
It reacts with moisture and produces what?
Oxygen.
No.
That forms phosphorus acid, sir, and hydrochloric acid, sir.
Formula. Tell me the reaction. Full reaction.
Sir, PCl3 plus H2O gives H3PO3 plus HCl, sir.
Okay, absolutely.
Balance also should we do, sir? Or
No, not
okay, sir.
Okay, so yes, so what happens, you see, when PCl3 reacts with water, you actually produce 2 acids. Out of them, only one of them is responsible for fumes. Which one is that?
HCl, sir.
HCl.
HCl is the one.
Should say HCl liberated, sir. With the
Yeah, HCl gas, exactly. That's the point. HCl will not be in the form of acid, it will be in the form of a gas. That is why you see fumes. Okay, good. Nice question, nice answer. Group 1 gets +2. Okay, group 2, your question. Okay, I have H3PO4, H3PO2, H3PO3, and H3PO2. Arrange them in the order of reducing power. And you have to give me a reason. Why are you doing this?
Sir, is it H3PO4, H3PO, sir, or PO2?
This is H3PO4,
Okay.
H3PO2, I mean H3PO3 and H3PO2. Okay, right? These are all there. You want, I have to do, you mean you have to arrange them in the order of reducing power, and obviously give me a reason for this. Why are you doing this? You have 1 minute. I hope everybody is taking on every question. Yeah, I think 1 minute got over. You want to answer? It's group 2, right? Yeah, group 2. Group 2, how many of you are there today present? All 4 of you are present. That is the same. That is the same.
Sir,
Yeah, tell.
you said H3PO4 is the least, then H3PO3, and then H3PO2.
Maximum. Okay, the answer is right. Okay, this is the order of reducing power. Why?
So because of the oxidation state, it decreases.
Oxidation state can be a reason, but the perfect reason is something else. Yes, you want to come up with the reason? The reason is oxidation state. Yeah, that's a okay-ish way to talk about it. Yes, here I have +5. I mean +5, +3, and +1 is what I have. Yes, obviously then I can understand that it undergo oxidation very easily. Yes, makes sense, but I have a little more perfect answer to this. No? Okay. So I'll give you
about the basicity.
wait. It will come only to group 3. I'll give you +1 for group 2. So group 3, you get to answer this. The answer is right, but what is reason behind this? Group 3 can answer. Group 3, you want to answer?
Sir, can you just give 1 more minute?
Yeah, sure. 1 more minute.
Sir, we are not sure, sir.
You're not sure?
Yes, sir.
Okay, fine. Rohan, you were telling something you want to tell now, but no mark
Is
for
it
that.
related to the basicity of the acid, sir? Oh,
Basicity of the acid, yes, it is somewhere related to that. How is it related to, you know?
Sir, can we talk about the bond, sir? POH bond, sir.
Yes, sir, that bond.
Exactly. Yes, you're coming correctly. How will you answer this question?
Sir, more POH bond means more acidic, sir. H3
Okay, correct. Okay.
H3PO, I think H3PO4 is more acidic, sir.
Yeah, okay.
More acidic means it is inversely proportional to the reducing reactivity, sir.
No.
Reducing
you
power,
gave-
sir.
No. The thing is, if you look at the structure of H3PO4, this is how it looks. OH, OH, OH. This is H3PO4. For H3PO2, you have one pH bond. This is the one which is responsible for reducing power. Obviously, for H3PO2, this is the structure. Now you see, in case of H3PO4, now remember that when I ask about reducing power, more and more is the number of pH bonds, because obviously pH bond means it can easily break and H can come out very easily. That's the point we're talking about. So H3PO4 has no pH bond. This has one pH bond. This has two pH bonds. So more is the number of pH bonds, more is the reducing power. This is how you must speak. Okay, obviously acid strength, what you told, everything is there. But how do you connect acid strength to reducing power? There is no such connection. The connection is between this P and H bond. That is what you have to tell. Okay, this will work only for this will go for another group also. HClO4, HClO3, HClO2. Again, the same thing will come, the reducing power. Okay, right? Everybody understood? Why is it like this? Okay, I hope everybody understood.
I have a doubt. So we can say that if less POH bond is there, more strong reducing power.
No. You must tell that more pH bonds are there, more reducing power. That's what you must tell.
Okay, sir.
Okay, right. Done. Good. Fine. I think the next question goes to group 3, right? Group 3, your question is, oh, not now. Just a moment, people. Okay, I'm sorry, guys. I told you there is a temple. So I just ask my question and then mute myself so that you'll not get disturbed while you're thinking or something. Right? Let me ask the question first. Okay. The question for group 3 is N2, P4, both of them are there, but P4 is more reactive than N2. Why? That's your question. You have 1 minute to answer. I'll mute myself. Okay. Okay, thanks for the stop.
Sir, is it because PO4 is at the lower part of the sorry. P4 is phosphorus is at the bottom of the group, no, sir. So when you go down the group, reactivity increases.
Not like that.
So is it the answer?
No, it's not the answer. No, it's not the answer. Okay. So I think, can I move on to group 4? You want to answer this?
So this P4 is white phosphorus, sir. It's very reactive.
No. Do not go for the allotropes of phosphorus yet. Right? Generally, whatever be the phosphorus, white phosphorus, black phosphorus, red phosphorus, generally, phosphorus P4 is more reactive than N2. Why? No answers?
Sir, can we say N2 is more stable, sir, than P4?
Yeah, exactly. Stability and reactivity are inversely proportional, right? Yeah, why
Yes,
is it stable? Why is it
it
stable?
has triple bonds, sir.
Correct. So N2 has a triple bond. What about P4? Can you draw the structure of P4 in a paper and show me on the video and show me, Rohan? Is it possible? Or ask your teammates to do it if possible. I want the structure of P4. I'll give you the mark, obviously, don't worry. Yes. But can you show the structure of P4? I want to know. Anybody for that matter, actually. Anybody knows the structure of P4? Can you please go for it and send me? Yeah, single bond P4 Harini. Yes, correct Harini. Correct Harini. Yes, absolutely. Okay, anybody can do that? 1 second, let me look into the videos if is someone doing it. First of all, anybody knows the structure of P4? Can someone at least tell me yes if you know? Do you know the structure of P4, how it looks? Okay, nobody knows. Fine, then I will do it. 1 second. Right. So now N2 I know is a proper triple bond, N triple bond N. Right. Obviously, it is very tough for us to break the bond, and that's why it is inert, or say less reactive, however you want to call it. But if you look at P4, this is the structure. P, 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 P. This is how the structure of P4 is. Okay, so that's why now this you see is it looks like a triple bond, but it's not exactly a triple bond. These I would consider them as single bonds only between one P, between two P's in general, right? Between this and this P, there is only one bond. Between this and this P, there is only one bond. Between this and this P, there is only one bond. Okay, all these are single bonds which I can break very easily. But between two nitrogen atoms, I have a triple bond. So obviously it is more stronger, so less reactive, and this is more reactive. Okay, right? Everybody got it? Very simple, very, very simple. Right. Okay, nobody gets the point for this question. I get the point. Okay, right. Moving on to the next question. I think this is for group 4, right? So group 4, your question is give the disproportionation reaction of H3PO3. I wanted to give me the reaction. You have 1 minute. And you must tell me how is it disproportionation, obviously.
H3PO3 gives H3PO4 plus phosphine. PH3.
Yes, correct. Okay. How will you prove that this is a disproportionation reaction?
Because H3PO3 has +3 oxidation state.
Okay.
And H3PO4 has +5 oxidation.
Okay. Okay. And PH3 in P?
PH3 +1 oxidation.
Check properly. What is hydrogen's oxidation state in this case? If you know what is hydrogen's oxidation state, then phosphorus can be calculated, right? What is hydrogen's oxidation state?
+1.
Yes, correct. Hydrogen is +1. So phosphorus should be
3, sir.
-3.
Correct. -3. Right. So you see, +3 to +5 oxidation, +3 to -3 reduction. So this is what the disproportionation reaction. Single molecule gets oxidized and reduced simultaneously. That is what is disproportionation. Okay, correct. Yes. Group 4 gets +2. Right. Okay. The question goes to group 1 now. See the same now, actually the same question which I asked here, right? Write the disproportionation reaction of this thing. I can even ask the question, what happens? This is not a question, I'm just telling what happens when H3PO3 is heated. You know, this is the same reaction. When you heat H3PO3, you form H3O4 and PH3. Okay, this question can be asked in this way also. Okay, this because H3 on heating H3PO3 only this particular reaction happens. Right, remember this. Write this down. Okay, fine. Now the question goes to group 1. Group 1, what you have to do is H4P2O5, right? Yeah, H4P2O5. Draw the structure and show me in the paper. H4P2O5. I want to know what is the structure, or you can send me in WhatsApp. Click it and send it to me. So send it to me in WhatsApp. I'm looking at the WhatsApp. Group 1. You have 1 minute.
Sir, I sent, sir.
Second. H4P2O5, POP 1, 2, 3, 4, 1, 2, 1, 2. Yes, correct. Right. So now the structure goes like this, people. H4P2O5, POP bond, 1 POP bond is there. Put 1, 1 double bond. So now I have put 1 OH bond. OH bond. Did you put OH bond properly? Yeah, I think. Right, and then how many over? So 1, 2, 3, 4, 4. I mean, 5 oxygens are over, 2 hydrogens are over, 2 phosphoruses are over. We have 2 more hydrogens. Just put 2 pH bonds. That's it. This is the structure for H4P2O5.
Sir, we can put the OH bond anywhere, no, sir? Like
Anywhere, anywhere,
hydrogen, okay.
anywhere. Not everywhere. Yes, it's absolutely correct. Okay, right. So you get +2. Okay, next question goes to group 2. Okay. In PCl5, I'm asking the question for group 2. In PCl5, basically you have 5 PCl bonds, right? Right? Not all 5 PCl bonds are the same, or I would say are of same length.
So can you repeat this question, sir?
Wait, I'm telling, not all 5 PCl bonds in this PCl5 are of same length. Why? Or justify this. Okay, we have 5 PCl bonds, right? All of them should have, we expect them to have similar bond length, same bond length, because it's the same molecule. But I see that there is a mismatch. It's not same. There is some difference there. Why and how? Justify this. Now this, if you have done your 11th class properly, this question is very easy. Yes, any answers? I think one got over.
Sir,
Yeah,
sir, there are two axial bonds and three equatorial bonds.
good, good. Okay, I'll give you the mark, but what you should tell the answer like this. Anyways, tell me what is the hybridization of PCl, of phosphorus in PCl5? What is the hybridization?
Sir, sp3, sir.
sp3. Now look at this. I need
DSP.
5. sp3d, not dsp3. It's sp3d.
sp3
Okay.
hybrid.
sp3d hybridization. I know what is the geometry of sp3d hybridization. What is the geometry of sp3d hybridization?
Bipyramidal, sir.
What bipyramidal? Just bipyramidal? Trigonal bipyramidal. Right, trigonal bipyramidal. Now you should tell, okay, in trigonal bipyramidal, there are three equatorial bonds and two axial bonds. That's why there is a difference. Right? You must write the structure also and show P, Cl, Cl, Cl. These are my equatorial bonds. And you have two Cls in the axial position. These two are axial. Right? So since I have two different types, axial and equatorial bonds, the bond lengths are not same. So these three Cls will have same bond length. These two Cls will have different bonds. Right? These 1, 2, 3 are in one category. This and this are in second category. Okay. So even though I am not fully satisfied with the answer, I am giving you a mark because you almost got it. Okay. Right. Fine. So I hope everybody understood. How do you answer the question? You must tell that phosphorus in PCl5 is sp3d hybridized. Since it is sp3d hybridized, the geometry is trigonal bipyramidal. In trigonal bipyramidal geometry, you have two types of bonds, axial and equatorial bonds. That is why we see that there is difference in the bond lengths of all the PCl5. Not all the PCl5, 3 in one category, another 2 in another category. That's why you must tell. Okay, right, fine. Next question for group 3. Interesting question. Let me see if I can answer this. That they are telling that NF3 is an exothermic compound, right? Whereas NCl3 is not. Why? Okay, NF3 is an exothermic compound, whereas your NCl3 is not. Well, okay, first of all, if you're wondering what do you mean by an exothermic compound, when NF3 is formed, energy is released. Okay, energy is released. Whereas when NCl3 is formed, energy is absorbed. That is what you mean by an exothermic and endothermic compound. Okay, if you're wondering what you mean by an exothermic compound. When NF3 is formed, energy is released. Whereas when NCl3 is formed, energy is absorbed. The question looks very complex, but the answer is very simple. Yes, any answers? Group 3. At least if you come closer to the answer, I'll give you the mark.
So is it because of the NF bond is stronger compared to the NCl bond?
Absolutely true. Yes, you're getting true. Right? So that's the point. It's all about the strength of the bond, right? NF bond is very strong, right? But NCl bond is a little weak, right? That's why, since the bond is very strong in the sense the bond is very stable, so obviously once the bond is formed, huge amount of energy is released. We generally know, right? When bond breaking happens, energy is released. Sorry, energy is absorbed. When bond is formed, energy is released. Okay. Now, obviously, when NCl bond is formed, also energy would have been released. But for making the compound, the energy supplied is way more than the energy released because NCl bond is not that strong. Okay, right? The only reason is that you have to tell NF is a stronger bond, NCl is a little weaker. That's why it's an exothermic compound, whereas this is an endothermic compound. As simple as that. Okay, good attempt. Okay. Next question goes to group 4. Right. So the question is group 4. The NO bond lengths in NO2 minus is shorter than that of in NO3 minus. Why? Obviously, the question is why, or explain how is this? The NO bond length in NO2 minus is shorter than the NO bond length in NO3 minus. Why?
So it's due to repulsion, sir.
No.
Intermolecular repulsion.
No. That means even if it is going to be there in NO3 also, right? Intermolecular repulsions. Yes, any other answers you have? Anything want to try?
Okay, to think, sir.
Okay, then. So the question passes on to group 1. Group 1, you want to try?
Sir,
Hmm.
I'm from group
Yes.
4. Can I try, sir?
You belong to group 1?
4, sir.
Group 4. Yes, please try. Yes, please tell me.
Sir, in NO2, there is one single bond and one double bond.
Okay.
In NO3, there are 2 single bonds and 1 double bond.
Okay. So
So
we are coming correctly. Yeah.
so the nitrogen oxygen bond length will be greater than NO2. No, NO3, sorry.
Like fine. I will give you 1.5. Okay. Fine. The answer is correct. I mean, that's partially right. Now you look at this. You look at the structures of NO2 minus and NO3 minus. So you have, all right, N double bond O minus. Here it is double bond, 1 minus. Okay, right. Now you see the average bond order. Basically, the average bond order means number of bonds between NO and this thing. Say now here I have totally 3 bonds between NO and this thing, right? There are 3 bonds for NO and between N and O, right? So can I say 3 divided by, there are 2 such structures like this. So 3 by 2 will become 1.5. Okay, right? 3, this become 1.5. Now here you check, right? How many bonds are there? 1, 2, 3, 4, 5 bonds are there, right? And there are 3 such scenarios, 1, 2, and 3. So 5 divided by 3, you will be getting approximately as 1.33, the bond order. Okay, so you see, we know that the bond length and bond order are inversely related, right? So a bond order of 1.5 means a stronger bond. Correct. So obviously the bond length will be smaller. But in this case, since they have a bond order of 1.3, you can see how am I calculating. Totally 5 NO bonds and 3 such scenarios. Here totally 3 NO bonds, 2 such scenarios. Okay, right. So 5 by 3 will come here 1.33. Here it will be 3 by 2 will come. So it is 1.5, 1.5. So this is the stronger bond than in this case. Okay, so that's why we have lesser bond length here in NO2, a greater bond length in NO3 minus. Good attempt, very good attempt. I thought you will not answer the question, but you got it. Very good, very good. Right. Okay, next question goes to group 1. What is the time, people? 11:10. I think I can go for one more round. Right. Okay. Right. Okay, the question is, prove that PCl5 is ionic in solid state. Give proof or give justification for this. PCl5 is ionic in solid state. Basically, you have to give me the proof how it exists in ionic state. How is it ionic?
Sir,
yeah.
Sir, in solid state, PCl5, like they prefer to exist in opposite charge, no, sir, like PCl4 minus and PCl6 minus, sir.
Tell me properly. Is it PCl4 what?
PCl4 minus and PCl6 minus.
How? Like there should be cation and anion, right? How can both be negative?
Sir, but PCl5 will exist in opposite only, no, sir, in the solid state.
Yes, Kanna, what you're telling, I'm able to understand, but there is little wrong. You're telling both of them will be negative and negative. How is it possible?
Sorry, sir, I think PCl4 will be positive, sir.
Okay. PCl4 plus, PCl6
yes, sir, and PCl6 minus, sir. And
yes.
The PCl4 is, I think it is tetrahedral, sir, and PCl6 is octahedral, I think, yes, sir.
Absolutely.
And they fit in the lattice structure, and
correct,
therefore
correct. Absolutely
thank
true. Right? So PCl5 in like PCl5 generally, right? It will be in gas. PCl5 is a gas. Okay. So now, but in solid state, it exists like this: PCl4 plus, PCl6 minus. Okay, and obviously this is tetrahedral, this is octahedral. So much information. Very good, very good. Right? So this is how it exists. So now the point goes. Again, group 2. Sorry, group 1. That's 2. Again. Okay. So for group 2, your question coming. Okay. Question is nitric oxide, right? Nitric oxide becomes brown when released in air. Why? Nitric oxide becomes brown when released in air. Why? First of all, if you're wondering, nitric oxide formula is NO. Okay, if you're wondering that one, right, I'm helping you a little. Okay. When NO is released into air, it becomes brown in color. NO is generally colorless. Okay, but the moment it comes out of it is released in air, it becomes brown. Why? Yes, any answers? Group 2.
Sir, it will react with oxygen in the air to give nitrogen dioxide.
Yes, absolutely. So, yes, correct. So you must write the reaction properly. NO plus O2 forms NO2. Now this is brown in color, right? That's the reason that I'm going to have one. NO is released in the atmosphere. It is very reactive actually. NO is a very reactive gas. Okay. The moment it is released, it is going to react with O2 to form NO2, which is brown in color. That's why it turns brown. Good, good, nice. So 2 gets a +2. Okay. Last 2 questions for the day. Okay, again we'll continue, right? Fine. Question is for group 3. Okay, can you, I have HNO3 reacting with P2O5, complete the reaction.
Sir?
Yeah.
Sir, I'm not very sure, sir, but this is my guess. Sir, will
Sure,
it
sure.
be HPO3 plus N2O5?
Yes, it is.
Okay.
Absolutely. Right. HPO3, what is the name of the acid? Anybody knows? What is the name of this acid? HPO3. Actually, this is not a monomer. This exists as a polymer. Okay, it's like HPO3 n times. That's how we write it. Anyways, so now anybody knows what is the formula? I mean, what is the name of the acid? Okay, so it's called metaphosphoric acid. Metaphosphoric acid. Okay, right? So yes, yeah, this thing group gets +2. Right, the last question for the day coming up. Yeah, the question is, why white phosphorus is more reactive than red phosphorus? Why? You have a minute to answer this question.
The white phosphorus is less stable than red phosphorus, sir.
Obviously, right? Obviously, that's not. This is like, why are you so tall? Because I'm not short. It's like that. What you're telling?
Due to its polymeric structure.
Sorry.
Polymeric structure.
Which is polymeric?
It is less reactive because red phosphorus is polymeric.
Okay. Red phosphorus is polymeric, right? So white phosphorus is normally P4 monomer, right? We already saw the structure for P4, right? The kite wala structure. Kite.
Yes, sir.
Right. For red phosphorus, this is how the structure looks, right? For I'll draw red phosphorus. Okay. For red phosphorus, so you have one bond, and this side obviously continues, and these bonds are there. Okay, but generally what happens is you have one more bond coming here, correct? That bond is not there, and that is going to continue to the next chain.
It will be P4N, sir.
Yeah, P4N times, exactly. Right, again, this bond will not be there, again it will continue. Right, so because of this becomes a polymeric structure, less reactive, but P4 is a monomer. I mean, white phosphorus is a monomer, so it is highly reactive. Okay, so yes, your answer is right. +2. Okay, so we'll stop with this for today. So I have a few more questions in group 15 itself, but you prepare group 16 and come. Tomorrow it will be group 15 as well as 16 questions will come. Okay, so I mean not tomorrow, whenever the next class is. Okay, group 15, little more questions will solve, and group 16. And let me tell you, if you prepare only the questions which you are solving in class, only that, right? You will be 90% of questions, or say 95% of questions in your exams will be able to answer. But you have to take down each and every group's question. Only if you take your own question, done, no point. Okay, so make sure that all the questions, all the answers we are discussing are in your notebooks. And only this you prepare, you are set for the exam. Trust me on that. Please trust me on that. Okay, right? Fine. So thank you so much, people. At the end, I think group 1 is leading, right? 8 points. Group 6 has 6 points. Group 3 has 6 points. And group 4 is just 0.5 points away from group 1, 7.5. Right? A very close competition. They are very, very, very close. Right? Go for it. Nice way. But I hope none of you are copying, none of you are cheating. I really trust you guys. If you're already doing that, please stop doing that. Okay. Thank you so much, people. We'll meet again next week.
Thank you, sir.
Thank you, sir.
Thank you.
Sir.
Thank you.